In this unit, we're looking at simple harmonic motion, but before we get into that, we need to talk about oscillations because that will then set the stage for kind of the specific example of simple harmonic motion. So, what we want to look at is first oscillations. And oscillations are any repeated motion. So if something is going back and forth, up and down, around in a circle, it can also be described as an oscillation because it's going through this cycle of repetition. And this will always happen, or this will typically happen because of a restoring force, or at least the oscillations that we're talking about are because there's some sort of restoring force. So if you remember way back to energy, we talked about gravitation, or we talked about potential energies having a restoring force. So gravitational potential energy is the potential energy associated with a restoring force of gravity. And our restoring force, just remember, is any force that has the form F equals negative and then a constant times a displacement of some sort. So if you stretch something farther, if you move something, it'll always get pulled or pushed back in the direction that it came from. So we can see some examples of oscillations. You've got an orbiting satellite, you've got an object driven by a spring. So if I've got, a spring attached to the wall here and then a block, and you push or pull it, you'd imagine it bouncing back and forth. And then, a pendulum swinging back and forth. That's going to be another example of an oscillation. Specifically in this class, we're going to be focusing on these last two. So if we want to describe oscillations, we've got three key vocabulary words. First, we've got period, which is how long for each cycle. And each cycle is just one repetition, right? So if it's going to go back and forth, a cycle would be swinging to the left and then back to the right, because then it's going to start over, swing to the left, back to the right. The variable that we use for period is typically a capital T, and the units are seconds or other time unit. So maybe you'll have a period of minutes, maybe you'll have, for the Earth going around the sun, that oscillation has a period of a year. But typically it's going to be seconds there. Frequency is how many cycles per time. So if you've heard like rotations per second, oscillations per second, rotations per minute, etc., those are all cycles per time, and so they're a frequency. The variable that we'll use for frequency is typically F, and I think I am totally blanking on what else we sometimes use for it. So let me check that real quick. Yes. Sometimes you'll see this with the Greek letter nu. It's like kind of a curvy V, but lowercase f is probably the best for this class to not get confused. Units are typically in hertz, and 1 hertz is equal to 1/1 second. And this could be or anything else, any inverse time. So if you recall, we said, rotations per minute, that's our inverse time, right? Per minute, and then 1 rotation per minute, or X number of rotations per minute. Amplitude is how much displacement from the neutral position. So if the restoring force is minimized, how much displacement have you, pushed or pulled from there? And typically when we talk about amplitude, we're talking about the max displacement, but there are places where you might say the amplitude is a certain value that's lower, but it's almost always going to be the maximum displacement. So if you look at your entire cycle of motion, what's the maximum distance that it, pushes or pulls compared to where the neutral or midpoint is. The variable for amplitude that we're going to use is typically capital A, and the units will be meters or other distance. It's a displacement, so anything that can measure distance, that is what we use. Sometimes on some edge cases you might see angles, but typically it's going to be positions. All right, let's get into the details now. That's oscillations in general. Now we're going to look at simple harmonic oscillators, which undergo simple harmonic motion. Which you can see we've been abbreviating as just SHM. So an oscillator where the only force is the restoring force undergoes simple harmonic motion and is a simple harmonic oscillator. So I'll give you kind of two examples here so you can kind of see the difference. Imagine we've got that spring and it's attached to a block and it's on the floor. If I push this spring in, you'd expect it to be pushing back, then I release it and it's going to vibrate back and forth. If the floor is frictionless, then the only force acting on this block in the direction of its motion is that spring force. So in other words, it's just going to bounce back and forth forever. There's no reason it's going to change its speed. That would be an example of a simple harmonic oscillator undergoing simple harmonic motion. If we add friction in, then it's going to become a, it'll still be an oscillator, but it's no longer a simple harmonic oscillator because that friction slows it down and it will eventually stop. In other words, it's undergoing damped harmonic motion. So the key with simple harmonic motion, or like what's interesting about it, is that it's uniform repeated motion, meaning it always does the same thing. It always goes to the same maximum. It always goes to the same minimum. It does it at the same constant kind of rate. Everything is the same. And so this is described with a sinusoidal function, which is just sine or cosine. So you'll have basically something that looks like this. Delta x equals a, cosine, and then a bunch of stuff in here that we're not going to worry about. But you can kind of see how you've got the amplitude, you've got the cosine, and because cosine goes between 1 and -1, you see that you go between the amplitude and the minimum amplitude, or positive amplitude and negative amplitude. In simple harmonic motion, you have a constant max amplitude, you have a constant frequency, and you have a constant period. So all of those are the same. They don't change no matter how many times you go through it. In this class, we're going to specifically look at springs and pendulums and kind of the motion that's going on there. So the next two videos will look at that. If you have any questions, let me know.